Welcome to the comparison of the Dijkstra versus Bellman-Ford algorithms. Both of these algorithms are comparisons of the both of these algorithms are the shortest path algorithms. This slideshow or presentation is all based on lecture material and the YouTube videos, content, and we're focused on mainly how they work and how they perform, and again, the differences between the two. So we have the thing of the wanting to know what the shortest path is, and both the Dijkstra and the Bellman-Ford algorithms are two weighted shortest path algorithms that solve that and find a shortest path, but they do it in different ways. They worked on weighted graphs, and they both compute the distances in all vertices. However, they are different in their logic. The main difference is Dijkstra can only work with positive weights. There's no negative weights in its graph. But Bellman-Ford can have negative weights, but it is slightly slower. Dijkstra works on a graph with or without directed paths. So it can have arrows pointing from one node to the other, so it's going directly to one from the other to create a potentially shorter path, or it can just be like a line, and that's like the only direction it can go. Or it can go either way, I should say, which is nice. As I mentioned before, Dijkstra cannot have negative paths, and then Bellman only works on general graphs and not either or. But it can handle negative weights. It's a little bit more flexible in that sense. In both cases, unreachable nodes will be infinity. That's just how it's designed for each one. Okay, so how does Dijkstra work? Dijkstra first starts at the source node, oftentimes referred to source 0, and sets that as a permanent, assuming that's the shortest one. But then it has a temporary node, and that's set and makes that permanent. And it continues down different paths until it finds a potentially shorter path. If there is a shorter path, it will update that and make that permanent. It relaxes the outgoing edges and continues until everything's processed. Bellman-Ford relaxes all edges repeatedly, finds the shortest distance, and finds improvements each round. Where Dijkstra may not find improvements every single round, because the way it updates to the shortest path, that shortest path may continue to be the same for a while, depending on the calculations. So that is one benefit of Bellman, even though it's a little slower, it can find improvements each time. So what about the edge weights? Like I mentioned, the edge weights have to be positive with Dijkstra. If you try to put negative edges on there, it would fail. This algorithm would not work at all. And as I mentioned, edge weights with Bellman-Fords can have negative, can mix positive or negative values. It still will work and still compute the correct paths, but it will require more rounds and a little bit more time. So the cons of Dijkstra, results may not always be correct because they can be negative, so there may be essentially never a shortest path because of the negative vertices. And it's less efficient for a larger data set. So upon initialization, both of them are set the origin to 0. Other nodes are set to infinity, especially if they're unreachable. They look at the data structures of the way it's set up, they prepare them, like whether it be the heap sort or however it's set, whichever one it needs. We'll get to that in a minute. And then they begin the relaxation process. So what's the relaxation concept? How does that work? They estimate the distance to kind of get an idea of what the shortest path might be and set that. And then if throughout the process the shorter path is found, they update. And then this is the main algorithm, main operation in both algorithms. However, the Dijkstra is a little bit more efficient because it makes the shorter path more permanent, whereas the other one can have negative values, ending up in a possible not short path. So Dijkstra relaxation only relaxes neighbors, and then if there's not a short path found, it will use its current shortest estimate. And then Bellman relaxes all edges each time through and repeats that v minus 1 times, it picks the shortest path. As I mentioned, Dijkstra will update each step. Each time it finds if it finds a smaller weight, it will update to that. Repeats for all vertices. Bellman-Ford also performs v minus 1 passes. The final pass checks for cycles and ensures it's correct. So data structures. Dijkstra uses priority queues, whereas Bellman-Ford uses simple loops. It doesn't have to be complicated with the structures, but it can be. It can handle either one. And then the heap sort in Dijkstra doesn't improve its performance. So basically with Dijkstra, it uses arrays. It has a time complexity of O V squared, and it is simple. Uses a binary heap sort. The big O, so the other one was time complexity. This is or I guess space complexity is time. Big O is O of V log V. It's common implementation of this. Complexity of Bellman-Ford, time complexity O of VE. Slower than Dijkstra, but it handles more cases. So as we mentioned before, it can handle the negatives, whereas Dijkstra can't, but it is slower in its performance. So kind of more of an overview again. Even though Dijkstra only works with positive edges, its results are very efficient and very good whenever there's valid cases within its algorithm. Bellman-Ford does always have a full solution regardless of the situation. It's more flexible because, as I mentioned, it can use negative. It can use pretty much it can use anything really with its algorithm. So what are some uses for Dijkstra? Dijkstra is used on things like a GPS system for complicated calculations, and then queries like SQL queries, looking up things, and then whatnot. And then in the summary, Dijkstra is more efficient. However, the Bellman-Ford is more flexible because it can use a negative value. And really your choice depends on not only what type of graph you use, but whether or not you know that there's going to be negative weights. Obviously, if you know that there's going to be negative weights, you have to use Bellman-Ford. Otherwise, in many cases, Dijkstra seems like it'd be the better choice, Biggest thing is you want to understand the trade-offs. What do you care about more? Do you care more about speed, or do you care more about flexibility? Either way, both are good algorithms. Just when you're considering between the two, think about what can do what. Thank you guys so much for your time. I hope you enjoyed this lecture over the weighted algorithms, and y'all have a good day.